Welcome aviators. This presentation will go over the heating optimization for the TBM900. The reason for this presentation is because we've received questions regarding the heating in the cabin. So hopefully after having watched this presentation, you have some questions answered regarding the operation of the system and how it behaves. Hopefully you've caught the other two heating optimization series that we've released in the newsletters for the TBM 850 and the TBM 930 and 940. All right, so let's get started. So the global air system, or GAS, is what it's installed on the aircraft since 2008 from serial number 434 onwards. This is referred to as a dual zone system. This means that there's different temperature controls between the cockpit and the cabin area. The global air system is composed of two separate circuits. One is heating, which in turn deals with pressurization and heating, and circuit 2, which is the cooling circuit. Both circuits are independent of one another, as we will see in the next slide. Here's an illustration of the separation of the two circuits. The red circuit is shown as a heating circuit. It uses engine bleed to provide defog and heating to the lower vents. The circuit you see in blue is actually the cooling circuit. This circuit uses recirculated air from the evaporators to provide the cool air to the cabin from the overhead vents. This is important to understand. As you will see, this recirculated air can cause the cabin to cool down unintentionally. To better understand heating, we expand a bit on the bleed coming from the engine. The bleed air sourced from either P2.5 or P3 air from a higher stage of compression in the engine. Switching into higher pressure bleed or P3 depends on a couple of conditions and is done automatically. First, the bleed will switch due to a pressure change coming from the engine or a temperature condition as requested by the cabin, as in if heat is needed. P3 source provides maximum heating. P3 operation is indicated by a high bleed annunciation on the torque indication. It is important to understand that this is not a fault, but a normal function of the engine operation, depending on the configuration necessary. So usually if you demand heat or there's low pressure or low power setting coming from the engine, the system will switch into a bleed high or P3 configuration. Okay, so let's review the functions of the cockpit and cabin control selection. We have illustrated that the cockpit control overrides the cabin control, meaning that if you have cockpit selected, then the cockpit will have sole control of the temperature. Makes sense, right? Conversely, on the other hand, if you have select cabin, both temperature selectors, cockpit and cabin, will have control over their associated zones. So, how do we optimize heating for the cockpit? It's important that we remember to use the cabin selection. In order to optimize the heating of the cockpit area, we suggest that you use cabin selection. It may be counterintuitive, but the higher the selected temperature on a specific zone will cause more heat being directed to that specific zone. If heat in the cockpit is needed, the temperature in the cockpit's temperature selector must be higher than the cabin temperature selector. So the control must be on cabin and the temperature must be higher in the area that you wish. So conversely, if more heat is needed in the cabin area, while still selecting cabin as the control, the temperature selection in the cabin temperature control must be higher than the cockpit. This will result in more heat to the cabin area. We must always remind you that the heating comes from below the floorboard, so please be mindful of obstructing the outlets for the heating. Make sure that all areas, exit ducts are clear of obstruction. Okay, so Here are the few points that we want to review for full heat configuration. First, under the 900, the AC selection should be in manual for best results. Control selection should be in cabin. The fan must be at 0 to avoid recirculation of the cool air, as indicated on previous slides. This comes from the cooling circuit overhead. Put all temperature selectors to full heat during climb to help minimize cold soaking. And then once you reach cruise, you may choose to increase the temperature as needed depending on which area might be the coldest. There are also some selections that we urge you to avoid during flight, such as the bleed selector to off, unless there's a POH action that tells you to do so. Max diff should never be used unless it is being used for some sort of medevac operation, so please avoid it. The AC selector must never be switched to off during flight. This will cause the system to go into a degraded mode and a default temperature of 23 degrees, which might actually reduce the temperature selection and prevent heating of the cabin. So please avoid turning the AC switch to off. And okay, guys, this concludes the heat optimization slide. As always, we have hotlines set up. If you have an AOG situation, call 1-844-4TBM-AOG. Should you have a technical question or need assistance or have a question about any of these presentations, please dial 1-833-TBM-CARE. You may also reach us directly at any of the numbers that you see on the card. We are here to support you. Thank you, and have a great day.